Welcome to this GED Math Booster video. The subject of today's video involves a problem where there are changes to the dimensions of a triangle. Here is our problem. A skateboard ramp has the dimensions shown below. If the skate park wants to build another ramp twice as high with the same incline means the same thing as angle, as the ramp below, how long will the new ramp be? We can see here we have a ramp that is 8 feet along the ground. It is 3 feet high at the end. We're looking at kind of the side of the ramp, and the length of the ramp is unknown. Now we could use Pythagorean theorem to figure out this missing ramp length, but this isn't really the ramp we're talking about. We are talking about a larger ramp. How long will the new ramp be? So we want to adjust this ramp size. And here we have a little sketch of a taller ramp that has the same incline or the same angle right here. Now, if this angle is the same, and it's also still a right triangle, meaning this is 90 degrees over here, that means that this angle up in the corner is going to be the same as this. That means that these two triangles are what are called similar triangles. And that means if we multiply one of the sides by a certain number to change it, the other side will also be multiplied by that same number. So in other words, in this case, 3 feet, if that's twice as high, this length will also be twice as much, and the ramp length will also be twice as long. So let's make those adjustments. This end, which I will call the height of our triangle, 3 times 2 is equal to 6 feet. And so we can forget about the 3-foot height. We're going to be thinking about just 6 feet. We will call B equal to 6. And along the ground here, 8 feet times 2, our length along the ground is now 16 feet. And we will call that A is equal to 16 feet. Now this distance, the length of our new ramp, we don't know. So we will call that C. This is consistent with our use of the Pythagorean theorem. Let's get into that right now because we know these two lengths. All we need to do is to use that theorem to find the missing length. Now just in review, here is that relationship. This is a relationship that is on the GED math formula sheet. C squared equals A squared plus B squared. If you've been in one of my classes, you know that I prefer to think of that as C is equal to the square root of A squared plus B squared. This is used to find the missing hypotenuse, like in our example. If we were interested in finding a missing short side, one of these two sides, not the hypotenuse, we would use a formula like this. A is equal to the square root of C squared minus B squared. And it doesn't matter which one is A and which one is B. You are going to use the one that you have in this side of the formula. And in this case, A is going to be the one that we don't know. For this problem, we are trying to find the hypotenuse. So we are going to use that formula. C is equal to the square root of A squared plus B squared. That is the square root of 16 squared plus 6 squared. Simplifying that, that is the square root of 292, which in your calculator will simplify to the decimal 17.1. Here's our answer over here, B, 17.1. And the key takeaway that you want to remember from this problem is that if you are given a situation where you have to make an adjustment to the size of a triangle, go ahead and adjust the size of that triangle first. Most likely it will involve similar triangles, and you can multiply each side by the same amount, and then use the Pythagorean theorem to find the missing length. That's it for today. I hope you found this video helpful.